Hi, everybody. My name is Paula Burke, and I am a senior backend software engineer at a company called Splitwise. In previous roles, I've worked on platform and infrastructure teams at companies like Stitch Fix and OpenTable. And in that time, I have spent a lot of time working with compliance teams as an engineer. So the purpose of this talk is just to talk a little bit about some of those experiences and the things that I've learned from them, and package it in a way that hopefully you can take some things away from it. So audit prep through engineering and compliance collaboration. This sounds a lot more boring than you might think. So I want to explain a little bit about why I think that this is important. So as an engineer on a platform team in particular, I would do a lot of work with the audit team at audit time. And they would come to us and say, like, we need to prove that this event happened in our systems. And I would spend a bunch of time digging through our logs and other evidence to produce it for them. And then they would come back and say, this isn't enough evidence for this. And I would be like, why? And we'd spend a number of hours doing this month after month after month. And then, as engineers, we do the thing that we always do, which is to say, like, hey, let's go automate some of these tasks away. And then when it comes, from an engineering perspective, that's really easy. We can say, like, yeah, let's do this kind of log collection and ingestion and alert on these things that we think are going to happen, and then like do some sort of automatic remediation of certain items. And that all sounds wonderful, but then when you go back to the compliance team and tell them all about this beautiful system that you've designed, they'll say, but you didn't consider all of these other things. So while it might seem obvious that we should work with the compliance team hand in hand as engineers, it actually is more difficult to do that because most organizations are not set up in such a way to support that kind of relationship. And so my goal with this talk is to, dig a little bit into some of the specific problems that arise in these kinds of relationship between these two teams. And then talk about some of the solutions that I've run into that have made it a lot easier. And so some of, my perspective is as an engineer. I've never worked on a compliance team. I am mostly talking to engineers when I talk through these things, but I think it would be helpful for compliance teams as well. So some of the key points I have here is just discussing a little bit about what this relationship looks like. It's something that most engineers don't run into if you're working on product, but you will eventually if you work on an infrastructure team or a security engineering team or IT, anything related to that. And then talking through some of the most common problems and projects these teams address together, and then talking through some of the suggestions that I have. So let me be really specific about the teams that I'm bringing into this discussion. For engineering, most compliance-related tasks for engineering will fall to teams that are called platform. Sometimes they're called infrastructure. Occasionally this sits with an IT team or an ops team. The way that many, technology companies have set this up varies quite a bit. And so usually falls into one of these teams, but they might be called something else at your organization. For compliance, I'm talking specifically about internal compliance teams, so not about the external auditors or interfacing with them. This is about cross-team collaboration within a single organization. And I'm speaking of compliance people who typically have a background in finance, accounting, or business and are working to move the company through audits on a regular cadence. So one of the places where the relationship between these two teams is interesting, and these kind of underlie some of the problems that we'll get to a little bit, is that they have different values. So engineering, our goal is to ship often and ship early. It's better to send code out into the world and see how it performs and get feedback as quickly as possible so that you can iterate on your projects and get to the best product market fit. We also, as engineers, want to avoid manual tasks. Nobody wants to be performing the same, tedious thing over and over again. And as engineers, we have the tools to do our own automation, and so we will often lean toward that as a solution. We want to fix issues quickly and effectively. So if we have to get in a database and change a record, engineers would really love to be able to do that so we can check it off the list and move on. And when it comes to prioritizing our metrics or, our risks, the thing that we look for is, keeping the site online. That's our priority. We want to make sure that our operations are running efficiently and that the site performs or the technology performs as expected. Compliance teams have values that are seemingly at odds with this. So they want consistency and completeness of data. They want stability of systems. So when it comes time to perform like a SOX audit on your systems, and account for all of the changes that have been made, moving fast and breaking things is much harder to track. This is why, we often automate lots of our compliance systems, but as you'll hear as I talk more about this, you can't really automate everything, and sometimes automation causes its own problems. And so, when we're seeking solutions to the same problem, both as an engineering organization and as a compliance organization, those are some of the conflicts that we run into are because of these sort of competing sets of priorities. So when do these two teams typically interact? There's sort of two main times that this happens. One is when the compliance team is verifying that controls are in place and functioning correctly. That's often during the big yearly audit, and it also probably part of tasks that are performed on a regular cadence, like often monthly or bi-monthly, depending on what they are. They'll have a checklist that they're working through and may need to reach out to engineering to verify some specific things. And then the other time that they interface, hopefully, but not always, is when significant changes are being planned or implemented. So when we are automating some compliance tasks, when we're changing the way that our systems function, or making any major changes that in particular would touch like financial data or PII or whatever industry regulations you specifically have to address, depending on the goals of the company. Some of the variables for this are the maturity of the organization. So, how large is the company? How long has it been around? Is it public? Is it private? Is it a nonprofit? Is it large or small? So that will obviously impact how often and how in-depth the conversations between these two teams are and how large the teams are. Also, the maturity of the automated systems. Even very large companies have lots of manual processes in place. Small companies may have had the opportunity to automate earlier, or they might, use a number of vendor solutions. That's kind of one of the variables. And then obviously audit and compliance needs. So depending on the industry, healthcare, defense, like I said, a public company working in finance, all of these are going to have different audit and compliance needs. So I'll be generalizing a little bit, and a lot of what I'm talking about applies mostly to like SOX audits, because that's what I have the most experience with, but it's pretty generalizable to any kind of audit where your engineering teams are doing some automation to cover that. So what are some of the common problems that teams run into when they're working, these two teams run into when they're working together? Commonly, one of them is defining scope. So when is a system going to be in scope for audit? It sounds like this should be really obvious, but it isn't in practice. So, when you're making changes to a set of systems and you need to add some functionality to one of them, you may have like A, B, and C are already under audit. And then you have another system that is not under audit currently. And adding that feature, would require, like maybe has financial relevance, and it makes the most sense to add it to the other system, to the system that's not under audit. But in doing so, you'd bring that system under audit. So these engineering decisions these engineering decisions can sometimes be driven a little bit by compliance, but this is one of those things that if you don't discuss it up front or your engineering teams don't really have knowledge of it, this isn't something that they might take under consideration. And so when you think about scoping out an engineering project, knowing whether it's going to bring something into scope that wasn't previously, that adds like an audit burden, that's one of the things that you can work with the compliance team to determine, like, how much more overhead is this going to give us? What does it increase our, footprint in a way that, we don't want to do? Is it going to require other changes to be made to systems? That's really important. And then the next thing is just who decides, what is the engineering team going to be the one to drive that decision? Does it come back to compliance? It's very easy to say like, oh, well, we'll work it out and somebody will decide, and somebody's manager or director is ultimately the person responsible for that decision. But having a framework for thinking about this or for making those decisions is really helpful, instead of having to decide it on the fly when you've run into the problem in the first place. And then the other thing that matters is, you have this set of systems, some of them are in scope, some of them are not. Who's responsible for tracking things and updating them? Where is the source of truth for the resources that are under scope? Do you have an internal system in place? Are you keeping it in a Google spreadsheet? Who's in charge of that Google spreadsheet? It's very easy to have things move in and out of scope and updated in one system, but not necessarily updated in other systems. You need to have a record of those changes. So those are some really common problems just in determining what even matters for audits. That sometimes comes back to engineering, sometimes comes back to compliance, but it's definitely a problem that the teams should work on together. Similarly, when it comes to automating our compliance systems, one of the things you run into is, when should something be automated? Like I said, engineering values efficiency. We would really love to not do any sort of manual tasks, but automating things brings its own set of problems. That if you're setting up an entirely new system in order to in order to abstract and automate away your audit time tasks, then that means that system is then also possibly under audit. It means you can't necessarily make changes to it frequently, because then those have to be recorded and accounted for. So when you're scoping out an engineering project to automate away some of your audit tasks, it's helpful to think of it in the amount of work behind it is not necessarily visible to the engineer when they think about it purely as solving the problem. And so that's where the second question comes in. So one of the problems is, how is the value of automation determined? Is it the amount of engineering hours that are saved? Is it the amount of compliance team hours that are saved? What do those person hours cost us? But on the flip side, it's like, are we expanding our risk profile, our number of systems under audit? How does that end up adding up? So you may find that while something is really tedious to do manually, but you only have to do it twice a year, as tempting as it is to automate it away, sometimes it's better to just clicking those buttons yourself, unfortunately. And then another set of common problems we've run into are exceptions. So, maybe you have a lot of automation set up, maybe you don't, maybe you're doing it manually. Regardless of that, there are going to be things that escape your system. In the context of like a SOX audit, it might be that you had a system that runs your deploys stop functioning, and then you have a manual system to follow that records it properly, but for whatever reason, the engineer on call didn't follow it, and so you have this like gap of information that didn't get captured. That's going to happen because these systems are built by humans, and humans make mistakes, and so rather than worrying about it, that there should be, these teams need to work together to find a system for reporting, recording, and managing any kind of exceptions to the controls. And not having that is a problem both for the compliance team and for the engineering team, who then has to go dig around and try to produce evidence that's satisfactory, which isn't always possible. So what are some solutions to these sets of problems? There's kind of two sets of them that I'll talk about, and one is cultural and one is technical. But in my experience, the most effective changes that we've made to address some of these problems have been cultural ones. So in engineering and in security, we have this method of incident response. When something goes wrong, we have a set of people who follow a set of protocols to get the organization through and drive the problem to resolution. And we do that because we want to avoid having a single person who's going to remember everything about our systems and is the only person who's available to fix problems and kind of acts as a superhero. And what do we do when that person isn't available or can't solve the problem? We don't compliance teams have superheroes too. You know, sometimes you have one single person who really understands the systems that are under audit and is able to stay up all night, you know, copying and pasting code and making sure that everything gets packaged and sent off correctly. And so just like we do in engineering and in security teams, we don't want to rely on one person to do that. And so one of the ways that we can avoid doing that is building collective knowledge. And that means investing in education for both the compliance and engineering teams that goes on regularly. So a lot of companies will have like a compliance training, and a lot of engineering teams have onboarding that engineers go through when they join a company. And that has a lot of explanations about, you know, how the systems work and what they need to do. But typically only engineers are the ones who go to the engineering training. But I've actually found a lot of value in having experienced compliance people join those as well, because understanding the way that systems are operated by the people who use them has given them a lot of insight into designing controls that are really effective and not intrusive. And on the other side, you know, you have engineers who kind of learn about controls or like audit kind of on an as needed basis rather than doing some comprehensive training. And it's not to say that your engineers need to be compliance officers or even know a lot about sometimes it's better if they don't really understand the controls. But having the perspective of like, you know, what is the goal of an audit? What are the kinds of things that the audit team needs? It's much better to do that up front with some training or education rather than like figuring it out on the fly and trying to determine what the goal of the other team is. So having that sort of cross-collaborative training has been really useful, and leaning on existing resources makes that really efficient. So have people attend trainings that already exist. If they don't exist, see if they can apply to other groups of people. It doesn't hurt to have a training for non-technical employees on the way that your engineering systems function. A lot of people find that useful for a variety of reasons, like customer support or something like that. So look for ways to get extra value out of those kinds of resources if you have to create them. And then one of the things that's necessary in doing that is getting executive investment in spending the time and the resources to build that collective knowledge. And the best way to do that is to track the resources that you're using in order to get things done on a day-to-day basis, and look for places where that can be more efficient. Their goals are aligned with both compliance and engineering, and so I think getting that buy-in early on so that you can spend the time to do some of these things is really important. But frankly, encouraging collaboration between these two teams is not expensive, really, in terms of people hours. It's especially if you're leveraging some of the systems that you already have. And then the last part is just focusing on the business value. I think that because engineers don't have a lot of knowledge of how the audit system works, they don't think of it in terms of they don't think of completing an audit successfully in terms of business value. It's not obvious, and it probably should be. So making that clear and really defining the value proposition in terms that both teams understand can be really useful, and getting cultural buy-in from both sides. And I didn't put this in the slide, but I probably have to say it. Engineers don't always do a great job of working with non-technical teams. They assume that those teams don't have the same deep set of knowledge that they do. And so you get a lot of mileage actually out of just increasing the respect between both of the teams and making sure that they are truly listening to each other. But from a technical perspective, there's other things that you can do to make this a lot easier throughout the year. One is partnering at the design stage. So engineering teams typically will consult with the design team and the UX team and the security team, hopefully, when they're designing new systems. And oftentimes teams will have a checklist of cross-collaboration relationships that they need to run through. And I would recommend adding compliance to that. If there's any reason that those systems are going to be under audit at some point, touching base at the design stage before it's actually been implemented is going to save you time later. So this is what I call just collaboration by default, making it part of the checklist. And this is particularly the case for things for automation. One of the and then one of the things that is really important in doing that is making sure that you're parallel testing any kind of automations that engineering teams introduce. So this should, I think that's a goal of everybody to do parallel testing, and that means that you run both systems at the same time and then compare the outcomes and make sure they're identical. So if you have a system that you're moving from a manual process to an automated process, make sure that you run both of those for as long as you need to feel assured that they're going to produce the same outcome. That is really critical for these systems in particular. And then when I talked a little bit about the exception problem earlier, one of the solutions that I would suggest for doing this is establishing SLAs for reporting exceptions. So this does not have to be a fancy or vendor-driven system. You don't need to come up with some entirely new process. But for cases that I talked about where you have an exception to the systems and you know that the auditors are going to come back and want more information about it, then it's helpful to use your current ticketing system, use an email form, have some, but do it in such a way where there is a very clear expectation for how long you have to report those exceptions and make sure that they're delivered to the audit team. And then, when you're working in a very high volume, and hopefully you don't have a lot of those, but you will eventually, having that reported in and the metadata captured in a meaningful way will be helpful in the future when you're making decisions about what to automate or what to automatically remediate. So that's where having some kind of form or some kind of system in place that captures metadata around the exceptions that you do have and feeds it to them is you're going to be able to do something with that data later, either analysis about what kind of hiring you might need to do to address different problems, about vendors that you might have to solve particular problems, and then making sure that those things are done in a timely manner and we haven't all moved on and forgotten what happened by the time it happens. So SLAs are really useful tools for setting expectations and providing a framework for things to get done. That's it. In conclusion, the thing that I hope people take away from this is that compliance and engineering teams have a lot to teach each other. And the places where they intersect shouldn't just be, at audit time when somebody needs like a code snippet in the middle of the night to prove that something functions the way that it does. We benefit a lot from having compliance teams who have a basic or advanced understanding of our tools and infrastructure, and how our systems function. And the best way to achieve that is to have ongoing relationships, cross-team training, and really sitting people who work together regularly, making sure that they have regular opportunities for collaboration, and that it's easy to do the right thing by default. So thank you.